This July, we got to go to OpenSauce 2025 in San Francisco. It was really an amazing experience, and we got to meet some of the creators behind some of the coolest new inventions and gadgets in the world. We got to give away another Bamboo P1S 3D printer. Congratulations to Sanvu from Berkeley, California. The robots were ridiculously fun and really inspired me to want to make my own robots in the future. There was tons of super artistic, creative, and just fun tech, and that's what this channel is all about. Wilson Fun Tech. Lots of weird crawling creatures. Quadrupeds, bipeds, tentacles, and of course lots of YouTubers. And did I mention robots?
Alright, hi! This is our open source humanoid robot project Aizee. So this is the first version here. This is made out of scratch from my apartment, and this was kind of me proving that I could make a humanoid robot and get it to function. So after I got this kind of functioning, I asked my mechanical engineering roommate, hey, can you redesign this entire thing to be 3D printed so that other people can actually build it? So that's what we got here. We got V1.5. It is fully 3D printed version of this one. We're gonna have this open source in a few months so that anyone can build. And the idea with this is that you have an Oculus Quest VR headset, and you can puppet the robot that way and see the world through the depth camera in the front. It can also show which way your head's moving. And then you start telling it, I'm gonna be doing this task, like picking up socks off the ground or doing dishes. It'll start recording how you puppet it to do that. And then we get this open source version of this robot in a ton of people's houses. They start training it themselves. And then together we all collect that data and we can start training the robot to do something really useful. And if you wanted to check out this project, I have it on my YouTube channel at Kinda Over My Head. And I will also have all the project files and like the CAD, the BOM, and the code will be on GitHub at github.com/ltrlab/Aizee. So right now, this took me about it was about $1,800 of parts, and we're trying to drive the cost for the open source version down to $1,500. Yeah, so we're Concept Bytes. We're just a group of YouTubers who just build cool things. And you can see walking table here is one of our projects, just formed out of laziness. Yeah, it's just a table that brings you drinks, and inside you got a cooler. We've been posting on social media for about a year now. We have a HoloMat system there, and we integrate with AI into everything we do. Our whole booth here is actually AI generated. So we asked ChatGPT what the coolest booth at this conference would look like, and then we spent the last couple weeks building this. So the image of that is over there on the poster, and then we've been recreating that ever since. So we're new to YouTube. Yeah. How's it going?
Very much prototypes, but on solid ground they move a little better, and on pavement they move way better. Yeah, they'll just vibrate around.
Hi, I'm Melissa. We're at a booth here to teach you how to get started with combat robotics. So you might have seen the 250-pound gigantic battle bus, but you want to start yourself. So this is the booth where you can play with 1-pound bots. These come as kits. This is a kit for a full combat bot. This is one where you can download online on printables, the Force Knight bot. The designs are all available, and you can buy the hardware here, assemble it, and this is where you can compete locally with the robot combat events. We also have the ability to spin a wheel, and when you win, you can win one of these mini bots, which are 3D printed mini versions of our big bots. And this is the Palm Beach bot. So we really are just trying to get people into combat robotics and pointing people to the different resources available.
I'm Joe with Delveria. This is a giant Alienware laptop. It's a 5:1 scale of a Alienware 16-inch laptop. So we have a large screen, working keyboard and trackpad and mouse, which we're here playing Minecraft with. We also have a head that you can slap for fun. So if you're at OpenSauce, come on down. Sure, you can find us at no bitrate on YouTube, TikTok, Instagram, and I think that's all.
I have no idea who built this robot garbage can and drove it around stalking people throughout the day, but whoever you are, I salute you. I want to thank Morris and Lawrence, two students that came with me to OpenSauce this year from the University of Illinois in Champaign. They helped me with a lot of footage and interviews in this video.
For Spark Labs 3D, we are basically just a group of mechanical engineers that wanted to make engines more accessible to folks. So we basically designed a V6 engine entirely from the ground up. Took a lot of inspiration from conventional engines, so Nissan's and Toyota engines. Wanted to make kind of the universal and very accessible engine for folks that want to kind of bridge the gap between, not knowing anything about engines and having done repairs on it correctly. So we've got a motorized version over here and the cutaway, so you can see all of the components moving. You can see the cam, the crankshaft, various pistons moving in and out. And our goal really is to make this open source, make it available for anyone to 3D print. We're going to be putting together in the coming weeks kind of assembly instructions and more information on, the engine, so folks can really learn more about engines and really become excited about it. We're a group of friends. We met in university, graduated a couple years back, and so we just want to make something of our own. So that's really all it is. We don't have a social media, but we do have a website, so it's sparklabs3d.com. We're going to upload all of our files over there, along with assembly instructions, information about engines, really just more of an educative or informative kind of thing. This is what it is. American Society of Mechanical Engineers. We're just a student club out of San Jose State. We're a project-based club, so we do a little bit of everything. Our goal and purpose is just to kind of give students a setting or like a medium to develop those skills and experience that they need to go out to the industry and get those jobs. Everything that you see here is a mix of like passion projects, projects for like the coursework, the standard coursework that we take, and then also competition projects. This is like an example of one subcomponent of a competition project. These are passion projects right here. And then this is like a course project right here. This is for mechatronics. This is just a little custom keyboard passion project. And this is for I'll talk more about this one because this is one of our bigger projects. It's for the electric human-powered vehicle challenge. Similar to like your Formula and Baja competitions, but a little smaller. It's human power. So the drive is through your legs. And you kind of just design, manufacture, and then compete with a bike all in 1 year. So our design for this year is 4-wheel suspension, all-wheel drive, and like steering on it. So it's super complex, but yes, we just have one prototype of the subsection right here. All of us here are mechanical or MEs, but our club's not exclusive to MEs. It's in the name, like American Society of Mechanical Engineers, but we're really open to anyone, like on campus, like EEs, compies, anyone that wants to join and just get hands-on experience with anything. We're more of also like a creative club, so if people have a project idea, we just give them the materials and teach them any skills they need to know to get those projects to be fully realized. But we're just a big space for encouraging creation stuff. QR code's down there. If it'll be in the video, I'm sure they can just scan it. It should take you to like our website. It'll have like our link tree and our Discord and stuff like that.
So I run a club at my university, which is the University of British Columbia. I'm from Canada. And we try to do low-cost workshops for students to learn how basic electronics works. So we made a little theremin so that people could interact with it. Our batteries are dead right now, but at least we have the breadboard so that people can see how prototyping is done for electronic work and stuff. And that's on top of our bigger Hexapod for today. And then we also have our bin of Lego and our Lego Hexapod, which I can turn on. There we go.
which just carries around people's creations. So we wanted to interact with the crowd and let them build something, and then we'd add it to the robot as it went on. And so it's been really fun to get to see what people build, and then we add it on as the day moves forward. I'm Hey Charlotte Ford on almost everything, and I do YouTube and Instagram, and I like to make content for like women in STEM and STEM education. Yeah, thank you.
Some of the most famous and winningest BattleBots legends were also there.
But all electronics, and specifically the main processor for the robot and the antenna, is all right there. So I'll probably do an array of smaller brushless, which should allow me to shrink the robot. The reason it's this tall is because that's how it's
Some components will take off that entirely, all these parts.
And amazingly, they even had a giant cube right in the conference where BattleBots could destroy random appliances. I think this was sponsored by Palm Beach Robots. It was a huge hit throughout the whole show.
So, hi, how's it going? This is our open source free printed Hexapod. We call it Hex 2. It's a first version on Hex 1, which didn't work very well. Now it's working just a bit better. The whole thing is completely open source, so anyone could download the models and build their own. Yep, so it's mostly 3D printed. Everything is printed except for the nuts, bolts, screen, and PCBs. The ultimate goal is really just it started as a way for the three of us to keep in touch after we finish school. Now we're just kind of having fun, keeping it going. This is Hex 2. We're about to start Hex 3. Hex 3 will feature like a LiDAR camera, things like that, so it has a more of an understanding of its terrain. It can find the optimal path through its terrain rather than what it does now, which is completely sensorless. We do a lot of trick to figure out how to walk, right? But we want to move towards a more high level approach. We have our GitHub, so it's QR code right here. And yeah, all the CAD code, PCBs, everything. It's all up on there.
Hello, I'm Jared. I have what you call DesignedByJared. I basically just, whatever comes to mind, anything I'm working on, I post it online, from robotics to metal 3D printed guitar. I also do some software stuff occasionally with augmented reality. Basically anything that comes to mind. There's really no main thing, just I think it's cool. I build it. And I'm here at OpenSauce 2025 this year, and I'm protecting my metal 3D printed guitar made from aluminum and made by PCBWay. Over here is my self-driving, self-balancing robot locomotive. Essentially uses electric scooter wheels that go 20 miles per hour and uses a vision system and an autonomous software to navigate itself. If you ask why I made it, no real reason. I just too lazy to pick up my food sometimes, and I thought, I guess nails do it for me. Yeah, that's basically what I did. You can find me at DesignedByJared, no spaces altogether. And I publish not that frequently. These things take time, take money, but hopefully I can definitely publish out more things quicker.
Hey, I'm Julian, and this is my modular one reel. So the idea is all the components are separately modular. For example, the battery and the bumper here are able to be taken out and removed. And the idea here is that if you want to fly with the board or if you want to carry more capacity, it's super easy. If you want to fly, you just pull it out, ship this separately, and carry this on. Bumper as well. This is like something that gets easily damaged. And if it breaks, you can just pull it out or replace it super, super easy. Yeah. The entire thing is open source as well. So my GitHub is right there. Download the files, take a look. Yeah.
He was kind of just watching me, taking care of our aquariums at home. And then he's like, oh, you keep looking around all the corners. I'm like, well, I'm trying to find all my fish. I just bought a bunch of nice cute ones. I want to make sure they're all here. And so he came up with the idea of maybe we could put different computers and cameras all over. That way you can actually see in all the corners instead of having to kind of put your hands in the water and move your stuff around to make sure you can find everybody.
Basically, we're trying to keep it as simple as we can. Raspberry Pis, simple cameras, dumb HTML, guys. It's all about making sure you can see and build for yourself awesome marine husbandry tooling. Neon tetras, Rasporas, anything you could wish. Cory cats chilling under the foliage, who cares? 3D print your own homes, build your own systems, enjoy marine life. It's a great place to be.
Yeah, but the robot framework already has a way to do it. You just have to.
All right, next time I touch the door, hang on.
Hi guys, my name is Tate. I run the STEM YouTube channel BackMacSci. I like making engineering projects that have plasma in them. I want to teach people about how beautiful plasma is and how it works. So a lot of it has to do with high voltage and how high voltage interacts with gases. And I also dabble a little bit in product design with 3D modeling, some electronics enclosures. And I really like collaborating with other science YouTubers and working together to make the coolest project possible. And yeah, for example, most of my projects, I couldn't have done it without other people. This project over here, my friend from Germany sent me the heart of the power supply. He made a custom circuit. Over here, these glass globes were sent to me free of charge by my friend Zerg in Russia. Over here, this project, this tube was given to me at a discount from my friend Wayne Stratman. And right here, this star of the show today at my booth is a plasma toroid generator that I didn't design this one, but I designed one of the original circuits, and mine burned up earlier today, and it's down there on that cinder block. And amazingly, a viewer or a viewer of mine, he had one here as well, and he provided his for my booth, so that was amazing. So you can't do this stuff alone, that's for sure. So shout out to all my friends helping me along the way. Yeah, I've been messing around with plasma probably since 2021, and so about 4 years of it being my main hobby. So what inspired me to do it is probably, well, Styropyro's video on making a spark gap Tesla coil. I just saw a bunch of parts on it that I could get, and so once I felt like I could probably build this by seeing how he made it, I was inspired to look into it more and learn more about it. So definitely from the YouTuber Styropyro inspired me to get into this.
Assistive climbing exoskeleton, which the idea behind it is to help beginner rock climbers, people who really don't have the kind of upper body strength to be able to get into rock climbing, help them be able to do pull-ups and do that type of full in strength that they need to be able to climb. This project started because I'm a kind of recreational rock climber, and for one of my classes in grad school, they said, here's $1,000, build whatever you want. And I was thinking of trying to do something related to rock climbing. So this is the project that I came up with. Let me see if I can power it on. But the project works such that you can control the each hand individually by pressing these buttons. And when you press the button, it spools in the motor, and you can toggle different levels of assistance to be able to give yourself level 1 assistance for easy rock climbing, level 2 to make it even easier, or level 3 where it essentially just lifts you up. What it'll do is it'll be calibrating first, where it pulls in the cable
until these stoppers hit the little washers here. When that happens, it recognizes that as the minimum position that the exoskeleton is allowed to go, and it never pulls more than that. And then anytime I press the buttons, it'll be giving me that assistance. So right now it's calibrating. It'll give me a little bit of clearance. And then it's in passive mode right now, where you just get a little bit of tension just to keep the cord taut. When I press the buttons, or actually I'll put it on high torque mode so it's a little bit more visually obvious. When I press the buttons, you can see it pulls in. So if I want to do a pull up and come over here, just press both buttons, and then it essentially just lifts me. I really have to do no work. It does all the work for me.
That was really cool.
Yeah, thank you.
So what is there a weight capacity, like a weight limit?
The motors are actually only at roughly 20% their maximum power. So they're more than powerful enough to entirely lift me. But I don't run them at full power because they will tear apart all the 3D printed parts and potentially me as well. So I have to be careful with that. So I've also had a challenge where I would challenge people to do more pull-ups without an exoskeleton than I can with. My maximum was 42. And then about an hour ago, somebody came in and did 43. So they actually managed to beat me. Alex is the guy's name. This is our leaderboard.
Channel called Nixie Eclectic, where I 3D model and 3D print ideas. And a lot of these are ideas that I showcase on my YouTube channel. And I basically make whatever I feel like making. So there's no like theme to any of it. So this is like a circuit building blocks. So if you close the circuit, you can flick the switch and then the components work. This is like a planetary gear system medallion. This is our SWAT planter, the Panda Dog. It has like a Bluetooth sensor, and then it shows information about the soil, like moisture, light conductivity, which has something to do with soil fertilizer, like how fertile the soil is. And what else? Temperature. And we added the CPU temperature there because it was getting kind of hot. The Raspberry Pi was overheating, so we just wanted to make sure that it stayed cool. I do some fishing content because I like to fish quite a bit. So I try to combine like 3D printing with making fishing lures and fishing related products. And this is kind of like a combination of my fishing related like interest with just like I like making gears, and I wanted to make like a automata. So I made this. And this is just something that I made. Like I had an idea, so I decided to make it. It's like a rechargeable citrus juicer. And yeah, I like making colorful things, as you can see. YouTube, I have Instagram. I also have a a printables account where I post like my 3D models for free mostly. And yeah, that's how you can find me.
We are UAVs at Berkeley, student engineering competition team from UC Berkeley. This year's our competition drone, 8 feet across and running two 6S batteries, 12S. With it, we get about 35 minutes of flight time and can carry a max of 60 kilograms of payload. This thing's got a ton of thrust behind it. Is fully autonomous and capable of doing autonomous mapping, object detection, and also GPS denied navigation. And then on to the left of it, we've got the airframe for our next generation VTOL. This right now is the base aerofoil. We were doing testing and wind tunnel testing in the next coming days, but this will be kind of a build upon. The other fun part of how we're going to test it, put a nichrome wire on the back of it, hook it up to the bigger drone, fly it to about 500 feet, drop it, burn nichrome wire, and then test out control surfaces. So you can find us on our social medias. We're on Instagram, YouTube, and our website, UAVs at berkeley.edu. Feel free to check us out. Constantly posting updates about how we're doing at competition and what kind of developments we're doing on all of our drone platforms.
So this is VLAB Education. We design virtual reality science experiments for students and educators that don't have access to a traditional science lab. There are many students out there who are either homeschooled or maybe go into a low-income district through no fault of their own will never get to do a science lab. Science is all about putting on a lab coat and going into the lab and actually doing science, not memorizing things off of a textbook. And I should know, I have 2 degrees in chemistry, and that's what I do every single day. We wanted to provide a way for anyone, anywhere to be a scientist, and that's where kind of VLAB education came from. We have 6, soon to be actually now 8 total experiments, and now we're able to support schools that want to do chemistry and teach chemistry that previously couldn't. So we do everything from teaching how to wear proper PPE, gloves, goggles, lab coat, how to use the proper glassware, to something as advanced as radiation and doing, like in this case, a double replacement reaction. You can even view what's happening inside the beaker when you are doing these experiments to help students visualize the topic. Our goal is to allow or essentially foster the next generation of scientists, because if you're never exposed to something, you'll never have the opportunity to pursue it.
The motion capture glove on the hand, collected a bunch of position data, and then trained the correlation between the position data and the motor position. So then you take the glove off and it works pretty well.
Right? 3, 2, 1.
The number.
Things that have happened, like a couple years ago, we had a guy just take his shoes off, and you could see his footprints in the cement as he walked around.
We go to Utah.
Oh, okay.
Yeah, you just they have different sites that you can go to.
It tells you to kill and it turns yellow. So then the first person gets the second half.
Thanks for watching and stay tuned for more giveaways and fun tech.